Hello students, let's continue the session on revision of arithmetic progression. We shall start with question number 4 onwards. Determine an arithmetic progression whose third term is 9, so A3 is 9. And when fifth term is subtracted from the eighth term, we get 6. Fifth term subtracted from the eighth term, so A8 minus A5 equal to positive 6. With this, I'll write a plus 2 times d equal to 9, and with this a plus 7d minus, I have to use bracket, then write a plus 4d equal to 6. On simplification, a gets cancelled, we get 3 times of d equal to 6. This implies d value is positive 2. Now find the first term. A will be equal to 9 minus 2 times of d, so 9 minus 2 times of 2, which will be 9 minus 4, nothing but 5. Therefore, the arithmetic progression is 5, 7, 9, 11 and so on. Next question, very important. Divide 56 into 4 parts in arithmetic progression such that the ratio of the product of their extremes, first and the fourth, this is fourth, to the product of means, second and the third, is 5:6. For our convenience, we consider let 4 numbers to be a minus 3d, a minus d, a plus d, a plus 3d. There's a reason behind why I consider in this format. Here they have given that 56 has been divided in such 4 terms of AP. So if I add these terms, a minus 3d added to a minus d added to a plus d added to a plus 3d, we get the sum to be 56. Here all d's will get cancelled and we will be left over with 4a equal to 56. Therefore a is 14. Therefore the numbers are 14 minus 3d, 14 minus d, 14 plus d and 14 plus 3d. These are the 4 numbers. According to the question here, the product of their extremes to the product of the means. So product of the extremes is 14 minus 3d multiplied to 14 plus 3d. These are the extremes divided by the means, 14 minus d and 14 plus d. The ratio is 5:6, 5/6. So further on simplification, we get it as 6 times 14 square 196 minus 9 times of d square equal to 5 times 196 minus d square. This equation has to be simplified. How do we simplify that? Here you can consider the product. Let us multiply this. We get 6 times of 196 multiplied minus 6 times 9 is 54 d square equal to 5 times 196 minus 5 times d square. If d square is taken together, we get minus 54 and plus 5, which will be minus 49. So the value of d square, let me wipe that, value of d square will be equal to 196 by 49, which will be 4. So the value of d is plus or minus 2. Thus numbers are a minus 3d, which is equal to 14 minus 3 times of 2, which is 8, a minus d, which is 14 minus 2, 12, a plus d, we get it as 14 plus 2, 16, and a plus 3d, which is 14 plus 3 times of 2, which is 20. If we are taking this negative 2, we get the numbers in a reverse order. Therefore, the required arithmetic progression is 8, 12, 16, 20, and these are the 4 numbers. Another important question, the fifth, qth, and rth terms of an arithmetic progression are a, b, and c respectively. Show that a times q minus r plus b times r minus p plus c times p minus q equal to 0. For that, let me consider the first term to be capital letter A and common difference be capital letter D. So the first term, the pth term is A. So the pth term is AP, which is equal to the first term capital letter A plus P minus 1 times of capital D. Similar way, B will become equal to A plus Q minus 1 time of capital D, and rth term, which is C, will be equal to A plus R minus 1 time of D. Now let me consider the left hand side of what is to be proved. A times of q minus r plus b times of r minus p plus c times of p minus q should be equal to 0 we need to prove. So let me substitute instead of a as capital A plus p minus 1 multiplied to d, that multiplied to q minus r, plus instead of small letter b we have a plus q minus 1 multiplied to capital letter D, then multiplied with r minus p, plus instead of c we have a plus r minus 1 into d multiplied to p minus q. We need to simplify this. How do we simplify? On multiplication with q minus r to these two terms here and r minus p to these two terms, p minus q to these two terms, I can simply take a as common and I'll be getting q minus r added to r minus p added to p minus q, plus I can take d as common. I'll be getting q minus r multiplied to p minus 1 added to q minus 1 into r minus p plus r minus 1 into p minus q. Look at this. Here all the terms are repeated here. One is a positive, another is a negative, so they get cancelled. We'll be getting a multiplied to 0 plus d times of, let's multiply this, q multiplied to p is pq plus minus pr minus rp, minus q plus r. I have multiplied like this, p multiplied to both these terms, then minus 1 is multiplied to both these terms, plus let me do the same thing here, rq minus r minus pq positive P plus Rp minus P minus RQ plus Q. So what do we get? We get D times of PQ minus PR plus QR minus QP plus RP minus RQ. Rest of the things like minus P plus P, they get cancelled. Minus Q plus Q will get cancelled. So look at this, PQ minus PQ, they also get cancelled. RP minus RP, they get cancelled. QR minus QR get cancelled. We get D times of 0. We get it as 0, which is right hand side. Next question. The sum of n terms of an arithmetic progression is 3n square plus 5n. The sum of n terms means Sn is given by 3n square plus 5n. Find the arithmetic progression, and also we need to find the 15th term. We all know that An is given by Sn minus Sn minus 1. Let us make use of this identity, this formula. Sn is 3n square plus 5n, and minus, in the place of n we need to replace n minus 1. 5 times of n minus 1. We get 3n square plus 5n minus, simplify this, we will be getting 3n square minus 3 plus 6n minus 5n plus 5. So here 3n square will get cancelled, 5n will also get cancelled. We will be getting 6n plus 2. So An is 6n plus 2. So the arithmetic progression is, in the place of n, if you replace 1, we get the first term, 8. In the place of n, you replace with a 2, we get the second term, 12 plus 2, which is 14. Place of n, replace with 3, 18 plus 2, 20, so on. And we are asked to find 15th term, which is A plus 14 times D. And A is 8. The common difference is 6 here. So on simplification, we get it as 92. Next question, question number 8. The digit of a positive number of 3 digits are in AP. Find their sum, and their sum is 15. The number obtained by reversing the digits is 594, less than the original number. Find the number. Whenever such type of question is there where 3 digits are there, we have to consider A minus D, A and A plus D. In one of the question where 4 different numbers were, 56 was divided into 4 numbers, they are taken A minus 3D, A minus D, A plus D, A plus 3D. The same way we have to use little logic and consider 3 digits to be, let 3 digits be A minus D, A and A plus D. Therefore, their sum of the digit, as per the question, A minus D added to A plus D, the sum of the digits is 15. We get 3A as 15, so the value of A is 5. The required 3-digit number is 100 multiplied to the place value plus 10 multiplied to something plus 1 multiplied to something. What is this something here? Let me change the color. Here 100 is multiplied to the digit a minus d, and 10 is multiplied with the digit a, and 1 is multiplied to a plus d. This is a general way of having a 3-digit number. For a 2-digit number, we have learned in our previous classes. In class 9th we have learned, in class 8th also we have learned. It's the general form 10x plus y. 10 multiplied to the digit, 1 multiplied to the digit. Same way for a 3-digit number, it is like 100 times the digit, say x plus 10 times the digit y plus the digit z. Therefore, on simplification, we get it as 100a minus 100d plus 10a plus a plus d. Let's further simplify. We get it as 111a plus 99d. Sorry, this is minus 99. Sorry, minus 99d. Number obtained by reversing digits will be 100 multiplied to a plus d plus 100, sorry, 10a plus a minus d. On further simplification, we get it as 100a plus 100d plus 10a plus a minus d. This is triple 1a minus 99d. Here we get positive 99d. Alright, now look at the statement here. On reversing the digit, is the number obtained is 594 less than the original number. So on reversing, we got 111a plus 99d. This will be equal to original number minus 594. So let's simplify. We get a term cancelled. 99 added to 99 will be 2 times of 99d equal to minus 594. So the value of d obtained is negative 8. Therefore, number is 111a minus 99d, which is equal to 111 multiplied to the first term. How do we find the first term here? The common difference has to be minus 8. What if I consider the numbers to be minus 3 and minus 5? If I consider these two numbers, the sum becomes minus 8. If we are taking 5 here, minus 99 times of minus 3, we get 555 plus 297, which will be 852. Let us cross check. On reversing the digit, we get 258, When 258 is added to 594, what do we get? 12, 1 carry, 15, 1 carry, 8. It suits here. That is why I have to consider 5 and minus 3 over here, so that the difference becomes minus 8. This is a little logical. If you solve it, you will understand. That's all for today's session. Thank you.